Hello, you're watching TelecomTV. I'm Guy Daniels. Now, BT's move to a common platform for its 5G network will deliver significant benefits to customers. However, given the scale and pace of transformation, this also creates some challenges. And joining me now to discuss how the CSP will overcome these issues are Reza Rahnama, who is Managing Director Mobile Networks at BT Group, and Alex Quach, who is VP of the Wireline and Core Networks Division at Intel. Good to see you both. Reza, can you first of all give us an update on where BT is in its rollout of the 5G network and specifically the 5G core?
Yeah, sure. So we have over 71% of the country now covered on 5G. 5G core for us is an evolution. We had to start with first building a cloud environment, which then we can host our non-standalone network. We've pretty much concluded that work and migrated millions of our subscribers into that non-standalone, fully containerized core. As part of that, we have an ambition of creating a dual core environment, all running on Quach hardware and working with our partners such as Intel in order to achieve that. Within that domain, we have now created quite a distributed 5G core across the country for both user plane and control plane. And that sits within the same environment as our EPC. We haven't launched any specific SA traffic on it yet, but we will do that within the next 4 to 5 months.
And Alex, what are some of the key challenges that you continue to hear about from operators in terms of designing and deploying the 5G core?
Sure. We're hearing very similar performance trends from operators all around the world. And notably that performance is still, was and remains foundational, both on the user plane and the control plane. Particularly with the move towards a standalone core on the control plane, service providers are actually seeing increased latencies due to the decomposition of applications, into containers and into microservices. They're seeing a lot of chatter between microservices. And so there's a concern that, this chatter is, creating latency and could potentially blow up the server count in their infrastructure. So that's one of the pain points that we work with service providers on. But I think, essentially top of mind for all service providers is now power efficiency and sustainability. How to reduce power consumption, how do we get the most power efficient infrastructure and overall set of applications out there. And then transitioning to cloud native architectures is also a hugely complex task. And this is why some operators have chosen to stay with vertical stacks. And yet others, such as BT and Reza's team have actually led the way to a common cloud-based platform for their network. And then last but not least, there are new security challenges that are rising beyond perimeter-based security that we've seen in the virtual EPC that comes along with cloud-native architectures and microservices. And we're looking to address some of those challenges now ahead of when the deployments are actually happening, but so that we have solutions in place for when that happens.
Thanks, Alex. Well, let's take a closer look at some of these issues then. Reza, what have been some of the key challenges for BT during this network transformation work?
Yeah, we had a number of challenges that we've overcome with our partners. I guess the very first one, when you start building a completely containerized platform, the very first step for us is to actually build an environment that can work in a standard Quach environment with the SDN, with the open source orchestration layer, and be able to then onboard number of different vendors, Kubernetes applications, and make sure it actually works end to end. So just that building things in that environment, multi-vendor environment, and building it in a containerized solution end to end was the very first challenge we had. Then the second challenge is after you build that, this needs to become optimized because you are only as strong as your weakest link in this network. So we then started to look at how to optimize this network end to end. So when you look at the core, the non-standalone as well as the 5G core, we worked with some of our partners, specifically with Intel, on a number of technologies such as DPDK, SRIOV, in terms of ensuring that the traffic throughput and stability of the whole stack is as stable as possible and as optimized as possible. And for us, optimization is extremely important. We look at optimization from the UU interface, from the UE interface, all the way into RAN, into the transmission, from that into our gateway, and how we distributed it through the user plane and how that works with the control plane. And again, working with Intel, we did a huge amount of work in optimizing where to use technologies such as DPDK, where to use technologies such as SRIOV, and that really worked in detail at the network card level on what parameters to set in order to make sure the stack, that means from the moment that the packet arrives into the network card to the moment that it arrives into the Kubernetes layers, into the container, is as optimized as possible. Then the other big one for us, obviously, capacity management is very important. The users use more and more data, and they expect to use that. The lot of new content, whether it's 4K, 8K, it uses more and more bandwidth, and you want to use that as best as possible. So the capacity in compute grows. Again, we worked a lot with Intel in terms of ensuring that capacity in this compute is as optimized as possible based on the number of workloads that runs on these server farms that we have. And I guess Alex touched based on that optimization and energy and the power that it takes to run quite a large distributed network across the UK is a big deal, not only from the cost saving, but also for our ambitions to be a carbon neutral operator. So we had a number of challenges, but again, working with our partners, we've overcome them. But it is a continuous improvement. We always look to optimize better. We always look to be more efficient in terms of our power utilization.
That's good to hear. A lot to consider there. And Reza, regarding the platform, the common platform you're using, why did you choose this approach? What benefits are you achieving today, and what do you expect in the future?
I guess the approach is we have to work with the best partners across the globe in order to build the best network in UK. And for that, the common layer, although it's a lot harder than it seems, the common layer gives us a number of advantages. The very first one is obviously the compute and the network infrastructure can be common across a number of mobile applications, whether it's IMS, whether it's the certain SBCs you have for your edge voice interconnect, whether it's your packet core, whether it's PCRF. All of that, a common infrastructure that is optimized for real-time communication is beneficial. It's quite difficult because every partner, every vendor has their own version of deploying their application, and maturity of microservices and cloudification of applications also differs between the partners. Some are by far more than Roto. For example, their application is more availability zone aware, and some aren't, and you have to factor all of that. And within the 3GPP environment also, you have to make sure they all work well together. So the common infrastructure allowed us to have a distributed network across UK that for user plane, we can be as close as possible to the gateways, regardless of what traffic flows into it, whether it's RTP, TCP, UDP. And also for signaling, again, it is as distributed as possible in order to be able to provide high availability. The other part is obviously in-life cycle management for this type of services is probably one of the hardest thing we go through. When you have an environment as big as what we have and a network which has a number of services and applications all running on a common platform, one of the things you come across is that you're always in the process of upgrading, whether you're patching for security or you're deploying new version of config or you're putting a new software in based on what some of our partners provide us. That in-life cycle management, if we can get it as common as possible, which is a lot harder than that you can imagine, that will give us a lot of capability that we can bring number of partners together and build an environment that is easier to manage. But again, this is something that is a process we're going through, is an evolution. The bringing of DevSecOps into running a mobile core, running an IMS, all of this is fairly new. Not only new to us, but new in industry. But again, working with our partners, we're achieving what we want and seeing the path to how we could be more optimized. The other one is security. Security is probably one of the it is the most important thing that we think about, and creating a secure environment and working towards a zero trust architecture. Again, should become simpler in that common architecture. So there's a number of benefits that I think this gives us.
Alex, if I can come back to you, Reza mentioned the importance of partnerships and the close relationship that your two companies enjoy. What else does Intel offer to ease this transition to a cloud-native 5G core?
Yeah, as Reza mentioned, this move towards a common cloud platform is simple in concept, but it's hugely complex in its execution, because you have to manage the interoperability between a number of different vendors now who bring in solutions that actually work differently. And so Intel brings in a tremendous amount of expertise in the lower level platform configurations. So from the CAS layer all the way down to the hardware, we provide verified reference configurations where we carefully align and harden drivers such as DPDK, Linux kernel, optimized BIOS and firmware configurations for OEM platforms. And we ensure interoperability between the OSVs and the OEMs for new platform introductions for deployment. It's actually quite complex when you have to align all those different versions. And then we also, equally importantly, align these pre-verified configurations with critical 5G core application vendors so that the entire stack is aligned on known working configurations ahead of deployment cycles. And that way we can accelerate time to market, time to deployment for new processor and platform technologies. Our goal essentially, when we work as a team with British Telecom or other service providers, our goal is to find and solve problems in our labs and not in British Telecom's integration labs. By that time, it's too late and there's just too much complexity happening. So we want to simplify things, remove complexity, and really, find and solve complex problems ahead of time. We also have internal tools such as our internal 5G core stack. It's an engineering stack that we do not productize, but we really utilize and work with service provider partners, such as British Telecom, to drive innovations, to show the art of the possible, so that we have new accelerators that come onto our processors, that are embedded in our processors, that can enhance performance, reduce power consumption, increase security, and really show what's possible and accelerate the pool of these capabilities through the ecosystem, so that these innovations can be taken advantage of from a time to market perspective. And lastly, we have a broad portfolio of building blocks from Xeon scalable processors, as well as foundational network adapter cards for the common platform architectures.
And Reza, what has the relationship with Intel brought to the implementation and deployment of your 5G network?
It's been fundamental to it. The partnership, we've As I said, this was a very complex, challenging project, and it's ongoing. It will never stop because we continuously try to do better. The know-how that Intel brings into, as Alex said, from CAS into what leaves the wire is absolutely fundamental in these technologies. We worked with Intel hand in glove for months in terms of looking at extremely low-level config and readjusting the network for the best performance. And that was absolutely priceless for us. So our partnership really goes deep, and we're looking forward to working with them on optimizing our 5G core network continuously.
So what is next, Reza, on your journey to build out BT's 5G network and new services and beyond?
So obviously 5G is all about now monetization. We want to see scale on the 5G SA, and when we launch it in more cities, we would like to see more users attached to it and see the growth in utilization of the SA itself. We're also looking at launching a number of trials within the next few months, specifically around slicing. One of our big applications for us in BT EE is going to be gaming. So, we're looking forward on building the network that is best for gamers, and those and learning and working with our partners how to do slicing and sub-slicing is really important, and specifically the value that it will bring to the customers. We're really looking forward to in order to do that. The other one for me is network as a service. We've got to bring the network closer to the development community. We've got to allow others to think about applications that they want to build. One of the things is this concept of connected applications, applications that require low latency, require reliable connectivity. So we can't think of all of that. But we want to be the best network for you to connect to safely and securely and provide services for your customers. And we are part of that journey. You can plug your application into our network and you can launch it. Obviously, the next big one is going to be around AI and AI applications. So we can see a lot of industry noise around what AI is going to do, where the edge is going to sit. That's another debate. How much more powerful the smartphone is going to become, and how then do you build a network that is capable for dealing with AI style application, both in the device all the way into the radio network and into the cloud and the core, in terms of the heavy compute that it needs and the reliable and secure communication that it needs. So a fair bit to look forward to.
Well, the rollout of 5G is a continuous process, as we've heard. It's a journey. Can you both reveal some details of what we can expect from your two companies as we move forward? First of all, Alex, what's Intel working on?
We have a number of different initiatives going on as we continue to see the rollouts of 5G, core networks around the world. I mentioned earlier, right, performance is absolutely critical. So continuous delivery of accelerators, more dense processors, more power efficient processors, greater synergies between the processors and the NICs to deliver more efficient platforms. That continues to be a focus for us. I talked a little bit about the control plane earlier and some challenges that we see with the implementation of microservices on the control plane side, how to reduce latencies that get introduced, particularly with service mesh technology that needs to come into. That's an area that we work on. Sustainability and power management, that's not, unfortunately, that's here to stay, right? I mean, this is a collective challenge for the industry. We recently delivered the Intel Infrastructure Power Manager for 5G Core, which is a piece of software that we make available to 5G application vendors and OSVs for them to take advantage of processor capabilities, power states within our processors, both in idle and active modes, where they can these applications can dynamically in runtime adjust processor frequencies and hence power management to follow the traffic model that's happening, within a service provider environment that can, be shown now to reduce power consumption in core networks between 30 and 40%. And we're going to continue building on that on a different number of use cases. Reza pointed out, AI is super critical moving forward as well. We have AI capabilities within the Intel Xeon Scalable processors that are fantastic for light inferencing. Use cases would include things like, power management, but also anomaly detection, network fault detection and healing, using a lot of analytics and inferencing coming out of the processors to help accelerate these AI capabilities for network management. And then last but not least, in the security space, not just perimeter-based security, but also as you move towards a microservices-based environment, when new security threats come on, the ability for Intel to deliver security in hardware as opposed to running a lot of software and having security based on software. Hardware-based security is key, and we'll continue working with the ecosystem as well as with service providers such as BT to have these solutions in place.
Thanks, Alex. And a final comment from you, Reza. What are we going to see from BT in terms of your collaboration?
It's very much similar to what Alex was mentioning. The collaboration with Intel will bring us more densification in terms of you getting more out of our compute, because, as I said, capacity is a challenge, continuously growing, and as we grow on a COTS hardware as well, we no longer buy specific appliances, so that's very important. We work with Intel on that. Our power and energy optimization is another big one. BT is a big user of UK grid, so we're trying to become as green as possible, and optimizing our network from the RAN to the core is critical. So we work a lot with Intel within the core domain. In terms of applications, I think again what Alex said and what I said earlier, the big items are going to be more interactive applications, whether it's AR, VR when they come, whether it's future vehicles relying on this network, and AI are going to be the big items that I can see. It's coming, the early stages, the network needs to get ready for these, the applications need to get ready to utilize a network such as these, but we'll be working with Intel on really getting this 5G network to be really in a good place.
Very exciting. Well, we must leave it there. Reza and Alex, good talking with you both, and thank you so much for sharing your views with us today.
Thank you for having me.